Hi, my name is Nick Guida. I'm the founder and CEO of Tamarack Aerospace Group. And today we're going to talk about high hot performance. When I say high hot, what I'm referring to is the weight, altitude, temperature tables that are in the AFM for your Citation jet. It's comprised of 4 tables, and it's really the first step when you're doing a flight planning. The FAA, for multi-engine airplanes, the FAA requires a climb gradient, a positive climb gradient, if you lose an engine on takeoff. So you have to be able to climb. If you can't climb, then you don't have a safe airplane, because then you may be able to take off. You're out of runway now, and you can't navigate around buildings or trees, and it's just very dangerous. So the FAA says you have to maintain a positive gradient. 2.4%, 3.3, there's different kinds of gradients. On a hot day, when there's high density altitudes, you end up with much reduced climb performance. And without good climb performance, you lose an engine, you're in bad shape. Density altitude is basically pressure altitude compensated for temperature. So you end up with much thinner air for the same altitude that you would be. Like, for instance, this airport's at 2,140 feet. When it's 30 degrees Celsius outside, it's like you're being at a 4,500 foot airport. Even on the East Coast, on a really hot day, you can get 4,000 foot density altitudes. It's not just for one type of flying. You can get into high density altitude situations anywhere in the whole world. I was at Colorado Springs a couple of years ago at a CJP convention, and there was a Phenom 100 there. And it was a 135 operation, and it was going to fly from Colorado Springs to Wichita. They legally could only flight plan with 2 stops. They couldn't make it nonstop because the airplane performance on the hot day like that could only take enough fuel to go about 150 miles. And then it had to get another batch of fuel, and it could only go another 150 miles. And then it could make the trip because it was in lower elevation. Think about that. Think about 2 stops to Wichita from Colorado Springs. And I know that was a Phenom, but look at the CJ. It's in a similar situation. There are times when you have to make a stop because just of high hot if you want to fly safely and legally. So our winglets, we don't just put a winglet on the end of a wing. We extend the wing and put a winglet. This increases the aspect ratio effectively about 30%. High aspect ratio wings are more efficient and reduce drag. And when you're taking off, you're at very high lift coefficients, and with one engine, your drag is greatly reduced. On top of that, the additional wing area allows for more lift for a particular angle of attack, and much better climb gradients based on the increased surface area and improved span loading. So here's an interesting example. At CJP last month, we were at Santa Fe, 6,000 foot. And so at dinner the night before we were going to leave, David Miller stood up and said, "Hey, remember, it's going to be hot tomorrow. So you may want to leave in the morning. If you want to carry the fuel you want to carry or the people you want to carry, you're going to have to leave when it's cold outside in order to make your gradients and to be safe." So there's a perfect example of that. And on a day like that, we could put 1,000 more pounds of fuel or 5 more people, 1,000 pounds worth of people, and still meet the same gradients that the flat wing aircraft meet. So this isn't just a complete practical utility type of benefit that this product delivers every time, every flight. One of my favorite things to do on demo rides is to do single engine climb performance. So we'll go to 9 or 10,000 feet, we'll pull an engine to idle, and we'll climb at V2 or V3 depending on if it's flaps 15 or flaps 0. And to see the smiles on these guys' faces, because it's such an incredible difference. I mean, we'll be climbing 1,600 feet per minute at 8,000 feet ISO plus 15. I mean, it's such a difference. You can feel it immediately out of the box. And this, to me, is so fun to watch people experience how much more safe this plane is if you did lose an engine, just how much more performance you would get. So I got a serious question to ask you. You're at Telluride or Aspen, and you have another 1,000 pounds that you could carry in your plane to take off safely. What would you use it for? More people, more fuel, more range? That's another hour and a half of flights with our winglets. You can get to altitude and go for another hour and a half instead of a half an hour or 45 minutes. This is the type of utility that we bring to market with these winglets because of the single engine climb performance that we provide through our active winglets. So thanks for listening, and remember, Tamarack takes you further.